In this video, we're going to talk about the basics of moles. We're going to learn about what they are, and we're going to talk about some of these important numbers and terms. Now, we're going to start from the very beginning on moles here, so no matter how much you know or how much you don't know about moles, this video will be a great place to start. So what's a mole? I'm not talking about the cute little furry creatures that live underground here. I'm talking about the kind of moles that are super important in chemistry. So a mole is a name for a specific number of things, okay? A mole is kind of like a dozen, right? A dozen is the name for 12 things, or 12 things in a dozen. Now, a mole is like this, but it's way bigger than a dozen. 12 things in a dozen. In a mole, there are 602 hexillion things. This is 602 followed by 21 zeros. 602 hexillion things. So a mole, like a dozen, is a name for a certain number of things. There are 12 things in a dozen. There are 602 hexillion things in a mole. This is a gigantic number. Now, here's one thing that confuses people about moles. They forget that a mole is a name for 602 hexillion things, and they think that a mole is an abbreviation for the word molecule. So many people think this. They see mole and they think, oh, you mean molecule. No, no, no. If I write mole, I don't mean molecule. I mean a group of 602 hexillion things, not a molecule. So there are 602 hexillion things in a mole. And just like a dozen, we can have a mole of anything, right? So we could have a dozen donuts, which would be 12 donuts. Or we could have a mole of donuts, which would be 602 hexillion donuts. Or hey, we could have jelly beans. A dozen jelly beans would be 12 jelly beans, and a mole of jelly beans would be 602 hexillion jelly beans. So sometimes people get freaked out about moles, but just remember they're a lot like a dozen. 12 things in a dozen, 602 hexillion things in a mole. You can have a mole of donuts, you can have a mole of jelly beans, a mole of cars, a mole of paper clips, a mole of bouncy balls. Just as long as it is 602 hexillion things, you got a mole. Now let's talk a little bit about this actual number, 602 hexillion. This number is often referred to as Avogadro's number in honor of the Italian scientist who discovered it. But now, check this out here, right? 602 hexillion. This is a gigantic number. 602 with 21 zeros after it. Think about what a pain it is to deal with this number, right? If you're doing math by hand, you got to write this out and like do your multiplication and division with 21 zeros. Even if you're using a calculator, you got to type in all these zeros and make sure you have the right amount. And then when you get your answer, you got to go back and count how many zeros your answer has. It's a total pain. So instead of writing out 602 hexillion with all these zeros every time we want to talk about moles, we tend to abbreviate this number. Now, as you may know, when we abbreviate numbers in math and science, we usually use a technique called scientific notation. And here's how we would abbreviate this number using scientific notation, okay? I got this big number, 602 hexillion. I find out where the decimal place would be. It would be right here. And now I move the decimal place until I have just one digit to the left of it, okay? And I count the number of spots. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And now this is my new spot because there is a 6, just one digit to the left of it. So I moved my decimal place 23 spots to the left. And that means that in scientific notation, I would rewrite this number as 6.02 times 10 to the 23rd. The 23 comes from the number of spots that I moved it to the left. So 6.02 times 10 to the 23rd is how we often abbreviate this gigantic number, 602 hexillion, when we want to write it out and use it, say, in math problems. Now, this is a convenient way to write this gigantic number in scientific notation, but it's also a terrible way to write it, because this number 6.02 times 10 to the 23rd, it looks terrifying, right? It's got this 10 with the exponent, 6.02 times this thing. It's like people see this number and they're like, oh my God, what do I even do with this? Relax, it's okay. 6.02 times 10 to the 23rd might look a little terrifying, but just remember that it is an abbreviation for 602 hexillion, that it is an abbreviation for this very large number here. And every time you see 6.02 times 10 to the 23rd, just remember that it is an abbreviation for 602 hexillion. Okay, so now we've learned what a mole is, how many things are in a mole, and we've learned how we can abbreviate this gigantic number, 602 hexillion. The last thing I want to do is give you a sense of how gigantic this number, 602 hexillion, how gigantic it really is. Okay? So let's think about this mole of jelly beans that we talked about earlier. 602 hexillion jelly beans, which you know now we can abbreviate as 6.02 times 10 to the 23rd jelly beans. These are all just 3 ways of writing the same number. Okay, if you had 602 hexillion jelly beans, that would be as large as the entire planet Earth. A mole of jelly beans would be as big as the planet Earth. That is crazy. Think about how many jelly beans that is. I mean, really, think about how many jelly beans it would be if your house were filled with jelly beans. Okay, that would be gigantic. Think about how many jelly beans it would be if every building in your town was made only of jelly beans, okay? Like, that would be a ton. Now, imagine how many jelly beans you'd have if the entire Earth were made of nothing but jelly beans. And that is how big a mole of something would be. Now, we could have also a mole of donuts, which would be 602 hexillion donuts, 6.02 times 10 to the 23rd donuts. If we had this many donuts and we stacked them on top of each other like this, and we had 602 hexillion donuts and we kept making this stack would reach from the Earth to the sun and back 200 billion times. This stack of donuts would reach from the Earth to the sun, back and forth 200 billion times. Again, think about how many donuts we would have if we just laid donuts down like this from like your house to your school, right? That would be a ton of donuts. Now imagine going from the Earth to the sun and back 200 billion times. That is how many donuts 602 hexillion donuts is. But now here's the thing, this is really interesting. We're talking here about jelly beans and donuts, but a lot of times in chemistry, we're talking about things that are much smaller. We're talking about atoms. Now, a mole of jelly beans would be as big as the planet Earth, but a mole of atoms is much smaller. Here, in this container, I have just about 1 mole of sulfur atoms. This yellow powder and these yellow chips are made entirely of sulfur atoms. And there are about 602 hexillion sulfur atoms in this little dish here. So think about this, right? Got 602 hexillion sulfur atoms right here. Now, 602 hexillion jelly beans would be the size of the planet Earth. 602 hexillion sulfur atoms can fit in this little dish. This shows us how absolutely tiny a sulfur atom is, how tiny all atoms are compared to a jelly bean. Really, a mole of these is the size of planet Earth, but a mole of these little sulfur atoms can fit in this dish. So when we're dealing with something as tiny as atoms, a mole doesn't actually take up that much space because the things that we're dealing with are so incredibly small that a giant number of them just isn't that big. So just to review what we've talked about, let's go over a few of the key points. So a mole is kind of like a dozen. except there are 12 things in a dozen and 602 hexillion things in a mole. We can write this number in a variety of ways. We can do 602 with 21 zeros after it. We can call it 602 hexillion, or most commonly, we can abbreviate this number in scientific notation as 6.02 times 10 to the 23rd. This number here, 602 hexillion, is often referred to as Avogadro's number. And now finally, at the very end of the lesson, we saw how 602 hexillion is a giant number. 602 hexillion jelly beans would be the size of planet Earth. But atoms are so tiny that a mole of atoms doesn't really take up that much space. So 602 hexillion sulfur atoms, for example, is a pretty manageable size. And that is an introduction to moles.